Hello everyone, this is Professor Lee again. So we are going to continue to investigate the uniform distribution, right? Uniform probability distribution, part B. So this is our usual learning object for these chapters, right? So general understanding of these functions, continuous probability function and uniform distribution, and some basic calculation in uniform distribution function. All right, so just to quickly recap, when we say the probability density function of this uniform distribution, it looks like this. Now, if you really think about this 1 over b minus a, well, at the end, this is just going to be a number, right? If we have a interval a and b, this is going to be a number, and that number is this number. So if you have, for example, fx equal 2, or I think some of you familiar with this y equal 2, right? Fx and the y is pretty much the same deal. So do you remember how to graph this one, y equal 2 in xy plane? Right. Well, if this is y, if this is x, y equal 2, that we draw this by a straight line, that this point is going to be 2, right? That's this function and this function right here, the graph of this equation or graph of this function. So when we say distribute probability density function looks like this, and we know that at the end this is just going to be a number, that function we can actually draw this with this line that crossing all the way through like that. But you see this restriction right here? That means we are using this straight line only between where? Only between x value is a and b. So technically speaking, we are only going to use part of this line, which is between a and b, just like that, right? So that describes this probability density function in uniform distribution, right? We talked about that. So this is the formula for mu, which is the mean, and this is the formula for sigma, which is the standard deviation, right? Okay, so let's say this example says the distribution is given like this, right? So let's interpret this. This x means this is a probability distribution, but this u means what? This is going to be uniform, right? This is a uniform distribution. That u means this is going to be uniform distribution. And remember that we had this restriction on x between these two numbers, right? So when we have this, that means that number is a and that number is b. So just by giving this, now we can pretty much figure out what that function looks like, what that distribution function looks like, right? So, we talked about this, but, well, let's recap exactly what they are describing right here. So this notation right here means that it's going to be between 0 and 20, and distribution function is going to be like that. So if we replace this a and b value, then fx is going to be 1 over B being 20 minus A being 0, right? This is A, so it's just going to be 1 over 20, right? A being the lowest value and the B being the highest value. Now, if I graph this one, right? If I graph this situation, it'll probably look like this, right? Let me actually draw a straight line down. Let's say this is f of x, this is x. Now we are considering number between 0 and 20. So let's say 0 is here. And let's say 20 is here. Then we are talking about this straight line and this rectangle shape. And that point right here is going to be 1 over 20. This number right there, right? So if we want, see this P, what do you think this P refers to? That's a probability, or you can think of it as a proportion. Now that's the same thing. So it's going to be between 3 and 12. So, just roughly speaking, let's say 3 is here, and let's say 12 is here. So figuring out this probability is same thing as figuring out this area of this rectangle shape, that between 3 and 12, just like that. So how do you figure out the area of this rectangle? Well, the base times the height, right? Base times the height. So the base is going to be the distance from here to here, which is going to be 12 minus 3, which is what? Which is 9, right? Which is 9. And this is the base. And the height is going to be 1 over 20. So area that we really looking for is going to be 9 times 1 over 20, which is 9 over 20. If you put it in the calculator, right, 0.45, just like that. Now, they are trying to put this in a way, in a formula form like that, saying that this value between C and D with the equal sign or without the equal sign. Now, in our last lecture, we talked about this, that these are the same thing, right? So figuring out this probability between C and D, which is, in our case, we are saying this is our C, this is our D. And that's the same thing as f of x, which is the height, D minus C, which is the base. So height times the base, that's what they're saying. So we figured out the f of x, the height, and we figured the base is just going to be 20 minus 0, which is just going to be 20. So it's actually, no. So, sorry about that. The base is going to be 12 minus 3 right here, right? 12 minus 3 right here. So that's going to be just 9. So it's just like what we did right here, right? So 9 over 20, which is 45. So answer to this 0.45, just like that, right? Just like that. Okay. Now let's discuss this example here. They say distribution is given as this. Same, same distribution from 0 to 20. They say find 90th percentile. Find the 90th percentile. Do you remember the percentile? What does 90th percentile? 90th percentile means 90% is behind you, 10% is ahead of you or above you, right? That's what it means to be 90th percentile. If my, let's say, exam score is at 90th percentile, that means below me, there are 90% student. Above me, there are only 10% student. That's what percentile means. So if we check out this situation, then, just by looking at this given distribution, we have this from 0 to 20. Now, what do they want? They want to find 90th percentile. That means they want this number. They want this number right here. They will give me this proportion as 90th percentile. That means this area is going to be 0.9. Well, how do you know it's 0.9? Because I know that entire big rectangle area is going to be 1, right? That's one of those characteristics, right? That's one of the characteristics. So I know that point right here is going to be 1 over 20. That's the height of this rectangle. So 1 over 20 times 20, which is obviously 1. So I know the entire rectangle, the big rectangle right here, area is just going to be 1. But I want this number, that below that number, area is going to be 0.9, which is a 90%. Okay, so how do you actually find that number? Well, I mean, this is how they do this, but I mean, let's think about this. Whatever the distance from here to here, let's say we don't know this, so I think they use the d for this variable. Let's say this is d. So the width of this rectangle that I want, which will give me the 90 percentile, this base width is going to be actual number d. So d times the height, which is 1 over 20, must be equal to what? 0.9, right? 90%. So how do I solve this? Well, you multiply 20 on both sides. So this cancels out. So your d is going to be 0.9 times 20, which is going to be 18. Your d is going to be 18. So I know that this number right here, d is going to be 18. And they are doing the same thing that we did in here in a little bit more formal way. Let's say this percent from the beginning to that number is going to be 90%, 0.9, right? So they tried to do the exact same thing. The base length, which is going to be from the beginning to that point, which is the D point, right? Beginning to that point, that's a beginning point right here. And this is the height. So, this is just, you don't have to worry about this minus 0. So it's actually that. It's like, if I rewrite it, 20 times D right there. So that D is going to multiply to the top. And that's what we have right there. Okay, so how do you find the D? You multiply 20 on both sides. Right, multiply 20 here, multiply 20 here. That bottom 20 and the top 20 cancels out. The other side is, 20 times 0.9 or 0.9 times 20, same deal. So it's going to be 18, just like that, right? Just like that. Okay. So, exact same setup. right? Exact same setup from 0 to 20. And this time, let's go for 75th percentile. So let me give it a little bit of time. Why don't you try it right now, right? Why don't you try to find that number D, which will give me that number below is going to be 75%, right? Remember that I really want you to try this one right now, right? So let me give you a little bit of time. And it'll definitely help if you start, drawing that graph, the box shape, right? From 0 to 20. And the height is going to be 1 over 20, right? Okay. And we want that D, right? Okay. Right. I strongly encourage you to try it on your own right now, right? Just by watching me do it, it's not going to do the job, right? So please try it right now. Right, so if I just recreate the previous graph, this is what it looks like. And what am I looking for? I want this number right here. Let's say this number is D, which will give me that number to all the way down to the end is going to be 75th percentile. So this area right here is going to be 0.75. I want that number right there, D. So how do you find this area? The base times the height. So this area must be 0.75, right? So 0.75 must be equal to this base width, or the length is just going to be D minus 0, which is D times the height 1 over 20. So how do I find the D? You multiply 20 on both sides. So this cancels out. This side only have the D. So it's going to be 20 times 0.75. So if you do this, D is going to be 15, just like that. Now, if you just consider the exact same procedure as like last time, I mean, it's the same thing. We want that proportion from C to D, C being the beginning, and D is going to be the number that we're looking for, which is 75. The fx, this works as the height of the rectangle. This one right here is the base, right? This is the base. So height times the base from 0 to D is just the D. And the exact same procedure, right? Multiply 20 on both sides, then you got 15. So from 15 down, it's going to be 75%. 15 and up, it's going to be 25%, right? Okay. Let's check out this example here. So random number generator picks a number from 1 to 9 in a uniform manner, right? And answer the following question. So first one, whoa, what are they asking? They want to define this distribution, right? Remember that one? We go back to some of those, right? Just like this, right? Right here. They say this X is going to be what? Uniform distribution from 0 to 20, right? So same thing. They want to describe this situation, any random number from 1 to 9 in a uniform matters. So what should this be? This should be what? Uniform from what number to what number? From 1 to 9. Just like that, right? And if you want better writing, it's right there. Uniform 1 to 9. So, you know, if I graph this, it'll look like this. This is a 0. This is 1. This is 9. Now, can we guess the height of this box? Give a little bit of time. How do you find the height of this box? Given that the height times the base must be equal to 1. Right? Let me give a little bit of time to find this height. Right? This should be what? I mean, if you remember the previous, right here, do you remember that height right here is going to be 1 over the upper number minus the lower number. I mean, that's what it says, right? B minus A. So if we go back to here so that you can, take a look at it, take a good look at it, like this, right? And that number right here is going to be the height right here, right? So when we go back to this, the height right here is going to be, we can say that's f of x, 9, the bigger number, minus the smaller number, over 1. So this must be 1 over 8. That number right here, let me get rid of that. Not the pen. Right here. So that number right here is going to be 1 over 8, just like that, right? So, I mean, that's basically the second question, right? Graph this situation, 1 through 9, and 1 over 8 is right there, right? Okay. I mean, 1 over, let me fix that mistake. All right, so 1 through 9 and 1 over 8, which is going to be this point right there, right? Okay, and that is the graph. Now, next question. Find the probability density function. Find the probability density function. So let's go back and recheck what the probability density function is, right? Let's go back to the earlier, right? Okay, so, I mean, it's not really, I think it was the one lecture before. Probability density function basically looks like this. The probability density function is that any interval between B and A over 8. So where do they get this 8? Well, this is basically B minus A times this height right here, right? That's the thing. So That's the probability density function for this uniform distribution. Okay, so there's a little bit of a mistake, then I fixed it. So this would be 1 over 8, right? And we are ranging from 1 to 9. And probability density function, if we go back to the earlier description, the probability density function for is fx equal 1 over b minus a. So I should stay a little bit so that you can take a good look at it. Fx equal 1 over b minus a. You can write it in this format, right, as well, or the same thing. So, and that refers to what? That refers to that line function, line equation. So if we go back to our question, probability density function is going to be f of x 1 over b minus a, which is 1 over 8, right? Just like that, right? Okay. Now, same question, right? Remember that the same question from 1 through 9, uniform distribution case, find the mean. Now remember, this is the formula to figure out the mean, and our graph is 1 and 9, like that, and that was 1 over 8, like this, and this is A and this is B. So figure out the mean is very easy, right? Mu is going to be A plus B, which is 1 plus 9 divided by 2. So 10 over 2, which is 5. Now, figuring out the standard deviation is basically the same deal, right? You put it like that, right? Square root over 9, which is B value, minus 1, close it, square over 12. This is a fixed 12. Fixed 12. It's always going to be 12 here. And you type it up in your calculator, and this is what you get, right? This is what you get. All right. So let me actually show you how to put this in the calculator, right? So we are trying to put this, right? Oops. Okay. We are trying to put this in a calculator right here. So this is what we are going to do. First, we are going to put this square root sign. So second half and this square root sign. And I'm going to type almost same thing as this. So 9 minus 1, close it. And I can use this and 2, or they actually have this separate square button right here. So I can do this. Or if I want to, I can, let me show it again. Square root 9 minus 1. I could have done just 8, since this is so easy calculation, and the power and 2. And I'm going to move the cursor so that I can get out of that exponent. And that divides by 12, just like that. And then hit enter, right? Then you see 2.31, I'm cutting it right here so that then 9 will change that 0 to 0 to 1. And that's how we got this number right there, right? Okay, so let me go back to the old screen. All right, so we got this number from the calculator. Now, the next question says, Find the probability between 3.6 and 7.45. Remember this graph right here between 1 and 9. And this height right here is going to be 1 over 8. And then, you know, between 3.6, let's say this is 3.6 here. Let's say this point is 7.45. And then we want this proportion basically, right? We want this proportion. And that's what this question is saying. We want that proportion. So we want this distance. How do you do that? The bigger number minus the smaller number, right? So bigger number minus the smaller number right here. Now that will give me what? That will give me the length of this base, which is going to be right here, multiplied by the height, 1 over 8, just like that. So if you type this one in the calculator, and that's exactly what you are going to get. Right, let me clear this one. Okay. And the same thing, but this one is slightly different. This one is slightly different. So let's talk about this case right here. Well, let me draw the graph again, right? So we have this graph, and between 1 and 9, 1 and 9. But this time it says we want x to be bigger than 5.87. So let's say this is like 5.87. I want x to be bigger than this number. So which area, which rectangle I'm talking about? X gotta be bigger than this. That means definitely this rectangle that I want. So what's the upper number? My upper number is 9. What's my lower number? 5.78. And that's the two number that I'm putting right here. The upper number minus the lower number, which will give me this base length, right? Which will give me the base length, and times the height. Height is just 1 over 8. Again, if you type it up in your calculator, this is what you get. Well, let me give you a little bit of time to actually type it up in your calculator and verify this result. So why don't you just type it up right now? Right? Why don't you just type it up right now and just verify this? So, not you gotta put the parentheses. 9 minus 5.78, close it, divide 8, and that's what you get, right? So for this type of question, just with the one side x, if you just draw this simple graph like that, then that's not too difficult to figure it out, right? That's not that difficult to figure it out, right? Okay. Next example, pretty much the same example. Now look at this one right here. This time, it's gotta be x smaller than 4.19. Again, told you that simple graph was gonna help us to see things. It's going to be from 1 through 9. The height is 1 over 8. And this time, it says what? X is going to be smaller than 4.19. Let's say roughly say 4.19 is right here. 4.19. So x value that we are looking for is got to be smaller than this. That means what? That means we are looking for this area. So what's my upper number? Again, 4.19. What's my lower number? It's going to be 1 because it's not going to go less than 1 because that's the lowest possible number. So just put it in that, which will give me this distance. I guess is 3.19, right, altogether. divide by 8 because we are multiplying by 1/8, right? Same effect, and that's what we get right there. So that is going to be this area right there, right? That's going to be this area right there. Okay, now this is handful, right? This is handful. So let's check out this. Do you remember this one right here? What is that? This is also known as the given, the conditional probability, right? Given the conditional probability. So let me actually recap this. Probability of A given B. Do you remember the formula for this? This is going to be probability of A and B. What goes under? The given part goes under probability of B, right? So that's how we interpret this conditional probability. So is that what we did? Is that what we did? Right, look at this. This is our A part. This is our B part, right? And let me get rid of this, right? It's confusing. Let me write it right here. So it's our A given B. So A and B, what goes under? The B given goes under. So remember that we are still dealing with this case that is ranging from 1 through 9. Now, and I'm trying to figure out this one right here. X is going to be bigger than 6. Let's say 6 is right here. It's got to be bigger than 6. And also, it's got to be bigger than 4. Let's say 4 is right here. Bigger than 4. And it has to satisfy this and this at the same time. So what area is satisfying x is bigger than 6 and x is bigger than 4 both at the same time? Well, this area, of course, right? X bigger than 4 would not satisfy x must be bigger than 6. But this area right here satisfy this A part and this B part as well. So the top is actually between 6 and 9. And that's what we have right here. All right, does that make sense? I hope that makes sense because that's the area that satisfies this first part and the second part. Right? If this is or, then this is a different story, but this is an and. So it's got to satisfy this A part and the B part. Now look at the condition part right here. X is just going to be bigger than 4. Where is it? Well, that's not that difficult to see. Bigger than 4 is this area right there. Right? That area right there. That's bigger than 4 area. So it's between what? 4 and 9, which is what we get from here. So how do we figure out the top probability right here? Probability that it's going to be between 6 and 9. Do you remember this one? 6 and 9. So the base, which is 9 minus 6 times the height. Remember the height was 1 over 8, right? 1 over 8. So this would be 3 over 8. Why is it 5? Oh, you know, that's the top part. Yes, that's the top part, which is what we get right here. Okay, what about the bottom part, which is probability that 4x9. So this is going to be 9 minus 4 times 1 over 8. So that's a 5 over 8. And that's the bottom part right there. So this is like fraction over fraction. So how do you deal with this fraction over fraction type? Well, this is how you do this. The first fraction, the top fraction, that you write it exactly the same. The bottom fraction, you are going to change that to a multiplication, but you are going to flip the top and bottom. So it's not going to be 5 over 8. It's going to be 8 over 5, just like that. And that's how you deal with this. These two things are same thing as this. So this cancels out. So this becomes 3 over 5. Just like that. Right? Now there's a lot going on here. Right? There's a lot going on here. So let me clear these things. And let me give a little bit of time to think in, right? Let's get rid of all these unnecessary lines. Right here. Oops. Okay. So conditional probability, using the old conditional probability formula, we rewrite this in this form. And then with the actual help of the graph, we figure out what the top really means. That really means between 6 and 9. And we also figure out what the bottom really means just by analyzing this graph. X bigger than 4 really means between 4 and 9, because 9 is our possibly highest. So we got these two. I mean, I can find that separately like that, and it became a fraction number, which is top one, another fraction number, which is the bottom one. All right, so how do you deal with the fraction over fraction? Like, let me rewrite it here, like A over B and C over D. That is AB times DC. Right? You might want to write this one down, right? If you're not familiar with this. So that's the basic procedure that we are using to convert this into a single fraction. Right? Okay. A over B, C over D. All right. Okay. Okay, let's move on. Another conditional probability question. Look at this. Again, let's say this is our part A, this is part B. This is going to be probability of A and B and probability of B. The given part goes under. And the rest of it is pretty much the same, same procedure, right? Same procedure. What does that mean? That X is going to be bigger than 2.7 and X is going to be smaller than 7.9. I mean, if I graph it here, say 1 and 9, change color, say 2.7, let's say right here, 2.7, let's say 7.9 is right here. X is going to be bigger than 2.7, and X at the same time, X is going to be smaller than 7.9. That must be right in between, right? That's how they got this top one. And X is going to be less than 7.9. That means 7.9 all the way down, but it's going to be stop at 1. That's what we get. So, I can just put it here. If I write it again, probability of 2.7x 7.9. How do we do this? Well, 7.9 minus 2.7 times 1 over 8, right? That's going to, if you do this part, that's a 5.2 divided by 8. And that's what we have right there. And probability 1 and 7.9. This is going to be what? 7.9 minus 1 times 1 over 8. So that's be what? 6.9 over 8. That's right there. So this is, again, fraction over fraction. So how do you deal with this? 5.2 over 8. The top part is exactly the same. The bottom part is going to be multiplication, but it's going to be flipped. 8 goes on top, 6.9 goes on the bottom. Cancel, cancel. That's going to be 5.2 divided by 6.9. Type it in your calculator. That's what we get, right? Just like that. So think about this and see if it makes sense, right? See if it makes sense. All right, so this is like a little bit confusing because they are bringing back the conditional probability concept. But individual piece is it's not that crazy, it's not that crazy. All right, all right. Okay, should we move on? Okay, let's move on. So now this is a percentile, right? Which what we tried, right? So same deal from 1 through 9. What value of x represent 80th percentile, right? So, this is the basic procedure, but if you graph it, it helps. 1 and 9, we want to figure out that number right here. We're going to call that number D. And below this is going to be what? 0.8 or 80, doesn't really matter, right? And this is what? Height is going to be 1 over 8, just like that. So how do you find this area from 1 through D? This length, which is D minus 1, times 1 over 8. That should be equal to what? 0.8. And that's basically what they have right there, right? D over D minus 1, because why is it 1? Because that's the lowest one, times D times 8. Divide by 8 is going to be 0.8. So multiply 8 on both sides, right? Multiply 8 on both sides. Then this 8 cancels out. Then this is just going to be 8 times 0.80. And then that's 6.5, right? This is 6.5. And add 1 on both sides, 7.4. So that D must be 7.4. That number down is going to be 80%. That means 7.5 is at the 80th percentile, right? Just like that. Now, similar question. What X will give you 60th percentile? So let me give a little bit of time. Try this one. Give a little bit of time. Almost same as the previous one. This is not 80, this time this is 60. So let me give a little bit of time to do this. It's always a good idea to start with a little bit of a graph. Okay, so we want to figure out this number D. 1 through D is going to be 0.6. 60th percentile, 606, same thing. So from D minus 1 times the height, 1 over 8 will give you this. That's going to be 60%. Right? I mean, that was 80% right there, and same format, right? So you multiply 8 on both sides to get rid of this bottom 8, and that's what you get. So 8 times 0.6, 4.8. Add 1 on both sides, 5.8. So that D really is gotta be 5.8. To have the 5.8 below is going to be 60%. Just like that, right? Okay, so that was it for chapter 5, uniform probability distribution. All right.